Welcome everyone. Here's another problem related to that lap winding and wave winding, but there is a little difference compared to the other problems that we have done before. First, to read the question, and I actually want you to solve this yourself. I'm not going to give you the solution of this answer, but I'll tell you the answer though. And before that, I need to explain something here. So in this question, you see that there is a term called duplex and simplex. Now what is this duplex and simplex? So basically this is nothing. The problems that we have solved before, so those are actually simplex winding, and I hope that you have understood that. So now what is the duplex? So basically in case of wave winding, we know that the number of parallel path is equal to 2, right? So A is 2. That is for simplex winding. So whenever in the question if it is mentioned duplex, so that means it will be twice of that. So in case of duplex, so A will be 4. That will be for duplex winding. And similarly it will be 3 times, so that will be 6. That is called triplex winding. Alright, so basically we are multiplying it by 2 or 3 as it is mentioned duplex or triplex. Similarly for lap winding also. So in this question it is 4, it has 4 poles. So in case of lap winding, we know that A is equal to the number of poles. So 4. So that will be for simplex winding. Alright. So similarly for duplex it will be 8 and 12 for triplex. I hope this is clear to you. So now you can solve the question, and the answer you will get, that will be 160 ohm. Okay, coming back to the next question. A 200 volt 4 pole DC shunt generator supply 50 ampere current to load. Find the current in each conductor if it's lap wounded. Armature resistance is 0.5 ohm and field resistance is 50 ohm. Till now we haven't discussed the type of generator. So I'm going to start with a little introduction of DC series and shunt generator. So in this question we are using shunt generator. I'm going to explain both the type. So in case of series generator, you have the armature winding and the field winding is actually in series, or you can place it here. Okay, so this is the series generator, and obviously the armature will be connected to the shaft, and this will generate the current. In case of generator, it will generate the current, right? So the current will come out from the armature, and this is where we connect the load. This is our load. Okay, so this here you will have armature winding, and this is called field winding. Okay, so what is the job of field winding? Field winding basically creates the magnetic field, and armature winding affects with that magnetic field generated by the field winding and start to rotate. Alright. In case of shunt generator, what happens? So you have the armature, okay, and the field winding will be parallel to the armature winding. That's it. Okay, so here I can write RS and here RSH, and similarly the load will be connected here, and here also the armature will be connected to the shaft. It will generate a current, and you see this current armature current will get divided into the field as well as towards the load. So here IA is actually equal to IF plus IL. Okay, and in this series generator, IA is equal to IL is equal to IF, because the same current is flowing through all the components that is connected, right? I hope this is clear. Now coming back to the problem. So it is saying that there's 200 volt. Okay, so in this question you have to understand this 200 volt that is mentioned here. So is that the armature voltage or the load voltage? Where is that 200 voltage we are taking? So any question, wherever you see any mention like this 200 volt something rating and all, that is actually measured from the load side. So if it is saying 200 volt, so that means, okay, let me just erase this part. Okay, so that means that 200 volt is actually here. Okay, now the armature voltage, that the generated voltage that we mention as EG, generated voltage. Okay, and there armature winding will have some resistance, let's say RA. So there will be some loss, that will be IA into RA, right? So if I use here, let's say VL. Okay, so if I use KVL, so EG minus IA into RA is equal to VL. Fine. Now the current, supplied current is 50 ampere, so that will be the IL. Okay, so IL is 50 ampere, but we have to find IA. So to find IA, we have to find IF also. So IF, you can write the VL by RSH. The field winding will have the same voltage as the load voltage because they are connected in parallel. So VL by RSH, that will be 200 by RSH is mentioned here in the question, that is 50. So that will be 4 ampere. Okay, so IA is equal to 50 plus 4, that will be 54 ampere. Okay, now what we have to find? The current in each conductor. So we got the IA, that is 54 ampere. Now how many parallel paths the machine will have? So number of parallel path, it is a lap wound machine. Yes, see it's mentioned lap wound, and you have 4 pole. So number of parallel path is 4. Again, if simplex or duplex, triplex is not mentioned, you have to assume that it's a simplex winding. So number of parallel path is 4. So the current is 54 ampere. So the current will be divided in all that 4 parallel path, and the current through each path will be 54 upon 4, that will be 13.5 ampere. So through all the conductor, the current will be 13.5 ampere. That is a final answer. Okay, I hope this concept is clear, whatever we have discussed today. And still, if you have any doubt, the comment section is always open for you. Thank you.